Hello guys, so today I'll be solving this problem. So the problem states that we have been given an array of apple of size n and a capacity array of size m. Now the apple array basically tells us what's the count of apple we have in the ith pack, okay, and the capacity array says that what is the ith box capacity, okay. Now the question states that we have to return the minimum number of boxes we need to select to redistribute this n packs of apples, okay. Now apples from the same pack can be distributed into different boxes. So yeah, that's the problem statement. So we have been given some, you can say, packets, okay. So if I draw out for this first case, okay, so these are like my packs, okay. Now this pack has one apple, this pack has three apple, and this pack has two apple, okay. Now we have been given some boxes. Now here we have five boxes. So like that we have been given these boxes. So there is one apple, let's do it in red, okay. There is one apple here, there are three apples here, and there are two apples here, okay. So in those boxes we have capacity like 4, 3, 1, 5, 2, okay, and here we have 1, 3, and 2. So what we need to do is we need to take minimum number of boxes and put all the apples there, okay. So the box count should be minimum, right? So how can we do it with minimum number of boxes? It means we should select the boxes with highest capacity, right? Like, or the highest capacity, okay. So one way to think is, so if I simply sort the boxes with respect to their capacity, so this will become 1, 2, 3, 4, and 5, okay. So if I am looking for minimum number of boxes, okay, that means I should take the uh, highest capacity boxes first, okay. Now the problem basically saying that I need to simply redistribute them, okay, and get the count of boxes. That's it, right? So that means the number of apples I have, which is here summation of maybe apple I, it's here 3 plus 2 plus 1, which is 6, right? So I will keep on choosing my boxes till I get to a point where my summation of capacity will be greater than or maybe equal to the number of apples I have, okay. That makes sense, right? I have 6 apple, so I need to select a few boxes so that I can get an overall capacity of more than or equal to 6, right? So what I will be doing here is, okay, I'll check, I'll start in the reverse order for my, in the shorted order. I'll start with 5, okay. I'll say, okay, I need a box for, like, here I have 5, here the total is 6, okay. So 6 minus 5, okay. So in this box I can keep 5 apple, then remaining apple will be 1, right? Now I can select any of the boxes here because I only need I only have one apple, so, and each one of them is like greater than equal to 1, okay. But what's the best way? Best way is to select simply the highest box only, okay, so that we will have a standard algorithm, okay. So next I will just simply pick 4, okay. I could have picked like 1, 2, 3 because those are like greater than equal to 1 only, okay. But I will stick to 4 because I am starting from the reverse order manner, okay. So I'll stick to 4. So now this capacity, my overall capacity will become 9, and 9 is greater than 6, okay. So with just two boxes I can fill 6 apples. So yeah, 2 is the answer here. Now similarly for this case, okay, so if I look at the summation of apple here, okay, so this is 3 5s, which is 15, okay. Now for boxes I have 2 4 2 7. If I sort them by capacities, then it will be 2, 2, 4 and 7. Okay, so I'll start selecting bigger boxes. Okay, so I'll first select 7. Okay, now I can keep 7 apple from this 15 apples, so I will be left with 8 more apples. Okay, so let's do it. 15 minus 7, 8. Okay, so now this is my remaining apple. Okay, now I'll select the second highest capacity box, which is 4. Okay, now with 4 I can put 4 more apples, so 8 minus 4, now I'll be left with 4 more apples. Okay, then I can select this box. Okay, so I can put 2 more apples, so 4 minus 2, I'll be left with 2 more apples. And finally I can select this box. Okay, so I will be doing 2 minus 2, 0. Okay, so I'll be consuming all 4 boxes itself, so my answer will be 4. Okay, so yeah, that's the idea. So simply get the summation of total apple, then short them, short the capacity in an decreasing fashion or maybe in an increasing fashion. If you are doing an increasing fashion, you have to start your iteration from the end, but if you are doing a decreasing order fashion, you can start from the first itself. So yeah, I will be coding the solution in Rust, so you guys will have a better idea. Cool. So first thing first, I'll be taking the summation of apples. So apple sum 0, or I can say apple iter sum. So this will give me all the summation of apple. Then I'll be sorting my capacity. So capacity ct, then sort by, I'll use a lambda a b this, and I will say when b is lesser than a. Okay, so because of the ordering change, my capacity array will be sorted in decreasing fashion. Okay, I can do it in an increasing fashion, but I don't want to use last pointers and keep on doing back. Okay, so basically what will happen is, so this array will become 5, 4, 3, 2, 1. So this will help me, like I only need to start from the first answer. So yeah, both will give you the answer, but I think I prefer this decreasing order fashion. Cool. So I have this capacity, this. Now I will create my answer variable, which is 0, and I will create a running sum for my capacity. So I will call capsum 0. Now I'll iterate over all the capacity here. So C in capacity. Okay, so here I will keep on adding my boxes, capsum plus equal to C. Okay, now I will update my answer. Now I'll check if capsum has become more than or equal to apple sum, then I'll simply break out of this, because yeah, I have gotten the many or number of boxes where my capacity is more than apple sum, more than equal to. Then whatever answer I'm getting, I will simply return that. Okay, I'm shorting this, but okay, it's not taken as mutable, so I can add this mut here. Then if I run, okay, all test case pass. If I'm submitting, and voila, it got accepted. So yeah, that's the idea. So if I look at the time complexity here, okay, so I'm doing a summation of this apple, which means I need to iterate over all the elements of in the apple array. So that means big O of number of packs of apple, packs. Okay, then I'm doing this sorting for my capacity. Okay, so if my capacity has, let's say yeah, my capacity has m elements, that means I'm doing a m log m sorting, right? Then after that I'm iterating over capacity again. Okay, and here all of this are constant time operation, that means a big O of m. Okay, so if I compare this and this, okay, this will override this value. So my final time complexity will look something like this. Okay, we go of number of packs, okay, plus we go of m log m. Okay, I need to consider packs because pack is not dependent upon the number of boxes I have. Okay, so it can increase independently of its own, so I need to consider this. Okay, then as per space complexity, I'm not using any extra space here. Okay, it's the input itself which I'm consuming, so there are no extra space, so it's a constant space. Cool. So this is the time and space complexity. Now I will quickly show you the code for C++. Okay. So in C++ code, I'm also doing the same thing. Okay. I'm doing the summation. Okay. Then I'm sorting my capacity in a decreasing order fashion. Okay. Now I'm keeping this running sum, and I'm keep on updating my running sum with the highest order capacity that I have. Okay. And I'm incrementing my answer with every box that I'm consuming. Now, whenever my total capacity is becoming more than my number of apples, I'm simply breaking out of it, and I'm finally returning answer. So yeah, that's what I did in um, Rust code. So the code is exactly same. I mean, not exactly same. The logic is exactly same. Cool. So now if I submit this, and voila, it got accepted. Now finally, I will show you Go code. So in Go also I'm doing the same stuff. Okay, so I'm creating apple sum, cap sum, and my answer array that will store the count of number of boxes. Then I'm summing up all the like the total number of apples I have. Then I'm sorting my capacity array in a non-decreasing fashion. Okay, then yeah, I have this capacity, then I'm iterating over capacity again. Now I'm updating my running sum by including higher capacity boxes first. Okay, now once my cap sum is greater than equal to my total number of apples, I'm breaking out of this because I know like after this I don't need any boxes. Okay, it's already sufficient. I will then whatever count I have received till now, I'm just returning that. So yeah, and voila, it also got passed. So yeah, all three languages done, and both have the same time complexity, number of packs plus m log m, and with a space complexity of constant. So yeah, I hope you learned something new. If you like the explanation, please do subscribe to the channel, and yeah, you can also like the video if you like the explanation. So yeah, and a note from me is like guys, please do comment, okay, in my videos, so that I will know like where I'm lacking in my explanation. That will help me as a feedback, okay, so that I can do better than what I'm doing now. So yeah, please do comment. Okay, cool. Just stay tuned to watch more videos. Thank you. Bye bye.